Okay. So if you look here, right, okay, another way to characterize or classify functions, okay, is to describe them as being even, okay, or odd, okay? Now, the actual definition of what makes a function even is that if you plug a negative x value into the function, it should be exactly the same as plugging in the positive x value of the function into the function. Okay? So if you plug a negative 2 into your function and you plug a positive 2 into your function, if you get the same y value, then that means that your function's even. And that should be true for all x values. Okay? Now, here's maybe a more important, here's maybe an easier way to kind of determine. The graph is symmetric about the y-axis, okay? Symmetric about the y-axis. That means you can kind of like fold it along the y-axis and it should line up, okay? So here's an example. Absolute value of x, okay? It's symmetric about the y-axis, right? Here's our y-axis. If we folded our paper along that line, this side and this side would perfectly match up, okay? And that's the idea about an even function, okay? Even function. Okay, so and that's their little trick right there. They say, can you fold the graph in half along the y-axis and it aligns perfectly? Then it was be even. Okay, now a function is an odd function when if you plug a negative x value into your function, it's the same as the opposite of f evaluated at the positive x value. Okay, so that's a little more complex. Okay, but here's maybe a different way to think about it. And again, the way maybe I want you guys to remember it. Okay, it's symmetric about the origin, or in other words, it can be rotated 180 degrees about the origin and it'll match up to itself. Okay, so maybe call this like rotational symmetry, but rotational 180 degrees. So you look here, here's the function y equals x to the third. Okay, and you can see that this function is odd, right? If we rotate it 180 degrees, so you kind of spin it, exactly 180, that's half of a full turn, okay? You can see that it matches perfectly back up, right? Kind of goes up from left to right, just like we see when we go this way, going up from left to right. Okay? So, does a function have to be either even or odd? The answer is no. Some functions are not even and they are not odd. Okay, so neither even nor odd. That's a possibility. Okay, so it's not every function has to be classified even or odd. Okay, so let's look down here. Letter A. Okay, how will we classify this function? Is it even or is it odd? Or is it neither? What do you say? Even? Okay, even. Yeah, it's even. All right, again, you could take that x squared, you could fold the 1/2, fold along that y-axis there, and these two parts would match up. So it is even. Okay? Y equals x. Is that one even? Is this even? No, if we fold along the y-axis, it's not going to quite match up, right? This upper piece would fold over to like here. This bottom piece would like fold over to here. So they don't quite match up. So it's definitely not even. Is it odd? Could we rotate? Yeah, rotate 180 degrees. And you can see it matches up perfectly back to where it was before. So yes, this one is odd. Okay? Even odd. Can you see a relationship here between the function and it being called even? Like what about this is kind of even here if you look at just the function itself? The 2, the power, okay? So the powers can kind of give it away, but you want to be a little bit careful because it doesn't always work out that way. But like for a basic like x squared, that's going to be an even function. For x to the 4th, it's going to be even. X to the 6th, it'll be even. Okay? If you start adding like other x's in or plus or minus stuff, that can kind of make it not even anymore. But in this case, it does relate to the powers. Okay? What's the exponent when you have just an x by itself? What's the exponent for this x when you have it just by itself? What exponent could we write here? 1. Is 1 even or odd? It's odd, right? And again, we end up with an odd function. So in other words, x to the 1, x to the 3rd is odd, x to the 5th is odd, x to the 7th, so on and so forth. Again, you start adding like other x's and things into your function, it's going to change that. But the basic parent functions can just follow those rules. All right, let's look at C. Is this one even? No, it does not have symmetry about the y-axis there, right? If you folded it, it would go off like this. Okay, so that's not quite right. Does it have rotational symmetry? Could you rotate 180 degrees and it'll match up perfectly? No. So it's not even, it's not odd, neither? Okay, neither is the answer there. All right. How about letter D? Is it even? If I folded this side over the y-axis, it would come over to here. Would that match up to anything? No. Okay, so it's not even. Is it odd? Can we rotate this thing 180 degrees and it would still match up? Yeah. Rotate 180 degrees. You can see there's still that piece. There's still that piece right there. So yeah, this is odd. Okay, 1 over x is odd. Okay, so hopefully you got even, odd, neither, odd there. All right. Questions on any of that? All right, so let's do A and B here real quick. All right, just to make sure we got this down. So example here, it says graph the following functions, then determine if the function is even, odd, or neither. Justify your answer by stating how the graph is or isn't symmetrical. Okay, so let's take a look here at this. All right, so we're going to pick some x values here. Now, obviously, with the way that our graph is here, we don't want to pick any random x values here. So let's just pick some. Actually, you know what? The time that I'm looking at there, I think I'm okay with just this. We'll just leave it at that. Well, yeah, we'll just leave it at that for right now. Okay, I think that's sufficient for right now. Hold on to this paper though. We might come back to another time. All right, but I do think that we're good there. So we'll just stop right there. All right. Did anyone have any questions on anything from the back that they saw? So, any questions from the back there? Okay. I'll ask this one right here. This one's a good one to ask about. Okay, number 4 on the back. Is this one even, odd, or neither here? It's neither, okay? Because the idea is, yes, if I rotated about this point, it would look the same, right? It still look kind of the same there. But the problem is, when you want to do odd, you have to rotate about the origin here. And so this thing would rotate down to here. It would not match up again. So this one is neither, okay? Is number 6 even, odd, or neither? Even. It does match up if you fold it over the y-axis there. So that one would be even, okay? So again, you're looking for matching up. Number 3, last one I'll look at here, and then we'll move on. 3, is it even, odd, or neither there? Even, odd, or neither, number 3. Odd. It's odd, yeah. If we rotate it, it will be back onto itself there when you do 180-degree rotation. Okay, so hold on to that. All right, that'll be good, review and stuff like that for you whenever we talk about even and odd again. Okay, if it shows up on a test or a quiz or something like that too. All right. And then the last thing I want to talk about here is transformations of functions. Okay. Let me see. How do I want to do this? Yes. Okay. So if you want to get your notes out real quick and a piece of paper, I just want to do a little bit more formal stuff talking about transformations of functions here. Because we kind of saw that activity yesterday, okay? But I just wanted to make sure we formally kind of state some things, okay? So you just want to add on to your notes from the past here. Okay. We're talking about transforming a function f. Okay. So, we saw some transformations yesterday, right? So I'm going to kind of trying to summarize those all in one big transformed function here. Let me see how I want to do this again. Okay. So I kind of put all the different transformations together here. We're going to talk about A, we're going to talk about B, we're going to talk about this H, and we're going to talk about this K here. Okay? So let's talk about A first. Now A, the number in front of your function there, that wasn't the first thing that you kind of transformed yesterday. The first kind of transformations you did dealt with this H and this K. But we're going to jump to the A there just because it's first. Okay, just to make it kind of keep it organized here, nice and neat. When we put a number in front of our function and we multiplied there, what kind of transformations resulted? So when you put like 2 times f of x or 1/2 times f of x, what kind of transformations resulted when we did that yesterday? What kind of transformations resulted? What changed about the function? So if you had like, 2f of x or 1/2 f of x. What did that do to our functions yesterday? Do you remember? Okay, stretched it. Is that what you're going to say too? Yeah. Yep. Stretched it. Stretched it or shrunk it, and then which direction? Up, down, vertically. Okay, vertical, stretch, or shrink. Yeah, okay. So, specifically, if A was greater than 1, so if the number in front was bigger than 1, was that a stretch or a shrink? It was a stretch. For the one outside, it was a stretch. Okay, so vertical stretch. Okay. Okay. And I'm going to put in parentheses here, multiply y coordinates by A. Okay. So in other words, what the vertical stretch does is it just takes your original y coordinates and multiplies them by A. Okay. So if the original function had a maximum of 2, then if you stretch it by a factor of A, it'll be 2 times A. It'll be whatever that A number is. Okay. If we wanted it to be a vertical shrink, what would have to be true about this number in front? What had to be true? What was that? Less than 1? Is that what I heard? Yeah, it's between 0 and 1. Okay, vertical shrink, again, multiply y coordinates by A. Okay. Okay, multiply the y coordinates by A. Okay. Having trouble seeing? Sorry. I can zoom in some more there. Oh, it's like a bad reflection or whatever. I can zoom in some more there too for you if that helps. Okay. All right. So that's what we did for there. All right. Now, what about, and I'll kind of like put a little squiggle there. Okay. What about this number here? What about when we multiply the number inside the function? So we had something inside the function like f of 2x or f of 1/2 x. What do these things do? What do we? Another stretch, but this direction was a horizontal stretch or shrink. Okay. Now in this case, it was the opposite of what you expected, right? When you started putting a 2 in, instead of it growing wider, it grew more narrow. Okay. So it's kind of the opposite. So in this case, we'll have to kind of be. So now if b is greater than 1, that's a horizontal shrink. Okay, in this case we would multiply, I'm just going to start abbreviating here, multiply the x coordinate by 1 over b. Okay, or in other words, divide the x coordinate by b and that'll shrink it down. Okay, so the y coordinates in this case would stay the same for the horizontal shrink. It's just the x coordinates are going to multiply by 1 over b. Okay, and then if you wanted to make it stretch, you would do any number between 0 and 1. So like 1/2, you put a 1/2 x there like that. That was a horizontal stretch. 2 more transformations we really dealt with yesterday. 2 more transformations we dealt with yesterday. Speed it out a little bit here. Okay. What did this h do? What did that h do? So if we had a number inside the function with the x, we added or subtracted it. So for example, if we had like f of x minus 2 or f of x plus 1. Okay. What did the x minus 2, how did that transform the function? Move it to the right, how many? Twice. 2 times, yeah, 2 units. And the x plus 1 moved it which direction? To the left one, okay? That's the exact opposite of what we would intuitively think, right? When you see a minus 2, you think, oh, minus, we should go to the left. Oh, plus, we should go to the right. When we are inside the parentheses here, it's the exact opposite of what we'd expect. Just like here, right? That b, okay, the b here is inside the parentheses. It does the exact opposite. When b is bigger than 1, it actually ends up in a horizontal shrink. When b is a fraction, like 1/2 or 1/3, something between 0 and 1, it actually ends up expanding it, stretching it, okay? When we are outside the function, this a here does exactly what we'd expect it to do. If a is bigger than 1, it's a vertical stretch. If a is less than 1 but greater than 0, it's a vertical shrink. That makes sense, you know, that makes intuitively sense. If half of something, it should shrink it, right? But it's the opposite inside the function there, so be careful with that. Now, I have it set up this way for a very specific reason. So in other words, I already have a minus h here. So if I subtract a positive h, right, if h is greater than 0 here, I'm actually going to move to the right h units. Okay, and then if I have h is less than 0 here, I will shift it left h units. Okay, so again, the purpose of this, I already put the minus in front of the h there. So now when I say a positive h value, it will really be minus positive, right? So minus, you know, if it was 2, minus 2 is going to shift right 2 units. But then minus a negative number, like minus negative 2, then we'll shift that left that many units. Okay? Okay. And then finally, what's this k? What's this k on the outside? What does that do? When you put a f of x plus 1 or f of x minus 2 on the outside like that. Shifts it up or down, right? Exactly right. So again, k greater than 0, shift up k units. K less than 0, shift down k units. Okay? And there's our transformations. I have one more I guess I want to talk about. Sorry, and this one's an easy one. If we wanted to reflect, how did we reflect it over the x-axis? What allowed us to reflect the function of the x-axis? What did we have to have? A negative in front of the function. So one other one here, I'll just put this one down here. Negative f of x reflects over x-axis. Okay, negative f of x reflects over the x-axis. All right? So, a couple things here. Bell's going to ring soon, I know. So, 1, no homework for tonight. Again, I know. How did you guys get so lucky? Well, the thing is, I'm going to have you guys work on stuff tomorrow in class. So, tomorrow in class, there's going to be a little bit of practice with this, okay? There's going to be hopefully a short video on inverses, and then there will be a little bit of inverse practice. So, 3 major things. A little bit of practice with transformations, a video on inverse stuff, and then some homework with inverse stuff, okay? That should be hopefully enough for you to work on in class tomorrow. All right? Please bring your Chromebooks. Please bring, if you don't bring your Chromebook, at least bring, like a phone or something like that, and please bring headphones too. I don't think I'm going to be able to have the sub project up here. Okay? And I can't guarantee the sub's going to know math, but you can ask Julia. Yeah, all right. Are you okay with helping people out, Julia, if they need it? Yeah, okay, so Julia will be able to help you guys if you have questions, okay? So please use her tomorrow if you need to. Okay? So bring your Chromebooks. That's your homework for tonight. Have a good day. Any set requests?